Hello boys and girls, welcome to Mrs. Bandu's Math Movies. This is for Algebra Lesson 3-4, Ratio and Proportion. Our objectives are to find ratios and rates and solve proportions. Okay, we'll start off with some key concepts and vocabulary. First of all, cross products of a proportion. If A over B is equal to C over D, then AD is equal to BC. Or if you want to look at that with numbers, 2 over 3 is equal to 8 over 12, so 2 times 12 is going to be equal to 3 times 8 if we in fact have a proportion. Both of these equal 24, so the proportion is true. Okay. It's just the very basic idea behind proportions. Okay, now we do have a few definitions we want to deal with. I'm trying to get this at a decent size here. Let's see. Anyway, okay, a ratio is a comparison of two numbers by division. And they can be written as A to B with the word 2 in between, A to B with a colon in between, or A over B. B cannot be 0 because division by 0 is undefined, as you will recall. Okay, a rate is a ratio in which the terms represent quantities measured in different units. Okay, like miles per hour or words per minute or something like that. A unit rate is a rate with a denominator or second term of 1. An example of that might be 25 miles to 1 hour, or 25 miles per hour is another way of saying that. So those would all be unit rates where that second term or the denominator is 1, something like that. Unit analysis is the process of selecting conversion factors to produce the appropriate units. For a ratio or rate. This is also called dimensional analysis as well. Just kind of FYI for you. We will investigate this in an example and surely spend some time with that in class as well. A proportion is an equation that states two ratios are equal. And that might be written A over B is equal to C over D, and B is not equal to 0, D is also not equal to 0 because they are both denominators here. Okay. In the proportion A over B equals C over D, the extremes of the proportion are terms A and D. Okay, the first and the last being extreme. The means of the proportion are B and C, or kind of in the middle. In the proportion A over B equals C over D, the cross products are AD and BC. And those cross products are going to be equivalent if you in fact have a proportion. And basically you will sometimes may hear the term that in a proportion the product of the extremes is equal to the product of the means. Or another way of saying that is that the cross products are equivalent. Okay, here's example number 1 using a unit rate. A brand of grapefruit juice cost $1.56 for 48 ounces. Find the unit rate. Okay, so basically what we do here is take the cost of $1.56 and divide that by the quantity, the number of ounces that the $1.56 purchases. When you divide that, that gives you 0.0325 or 3.25 cents per ounce. We don't always round this to the nearest cent. It kind of just depends on basically the situation that we're involved in. Oftentimes, to the nearest cent may not be enough information if you're trying to compare. You may need to have these extra decimals. So don't automatically just round them off. Go ahead and write it out as what you find. Okay, applying proportions. Let me make this a little bit smaller. Okay, in 2000, Lance Armstrong completed the 3,630 kilometer Tour de France in 92.5 hours. Traveling at his average speed, how long would it take Lance Armstrong to ride 295 kilometers? Okay, so first off, let T equal the time needed to ride the 295 kilometers. Okay, so what we'll do here is take the Tour de France average speed equal to 295 kilometers average speed. Okay, so that's going to give us 3,630, the distance traveled, and the number of hours, 92.5, all right, equal to 295 kilometers by the number of hours that it's going to take to ride that distance. And we set them equivalent to each other. So we have 3630 over 92.5 equal to 295 over T. And we do our cross products here. So that's going to give us 3,630 T times 92 times 295. Oh, 92.5, excuse me. Okay. At this point, I believe they left too many boxes here, so I'm just going to scratch this one out. The product here of 92.5 and 295 is 2,000. 27,000, excuse me, 140. Okay. So we'll divide each side by 3,630. And we get T equal to approximately 7.5 when I round to the nearest tenth, because also here I divided by 3,630 to get the T. 27,140 divided by 3,630 is 7.5 to the nearest tenth. So it would take him about 7.5 hours to cycle 295 kilometers, going at the same speed as he did in that Tour de France. Alrighty, and converting rates. Here's where we have to use the conversion factor, or the also known as unit analysis that we talked about, defined earlier. Okay, the fastest recorded speed for an eastern gray kangaroo is 40 miles per hour. What is the kangaroo's speed in feet per second? So the first thing I'm going to do is write what I know, 40 miles per hour. And be sure that you include your labels. Now I want to convert miles to feet, so I'm going to do a conversion factor of 5,280 feet to 1 mile. So that's going to take care of miles to feet. Okay, then I need to convert hours into seconds. So the first thing I'll do is do the conversion factor for minutes. So 1 hour is 60 minutes, and 1 minute is 60 seconds. So I have a series of conversion factors here. Some people like to do this as a series of smaller problems. If that makes more sense to you, I'm not going to be overly freaked out by that, so don't you be freaked out by it either. So I'm going to fill in 40 miles per hour, and then this is 5,280 feet, and then 60, and then 60. I just filled in. Now what we do is we divide out the common units. So the miles here crosses out the miles there, and it leaves me feet behind over here. The hour here crosses out hours. Minutes crosses out minutes. So what I'm left with is feet on the top and seconds on the bottom, which is exactly what I want, feet per second. So that's your goal. You have to keep that kind of in mind as you're working through this. So what you end up with, 40 times 5,280 is 211,200. And your second term here, 60 times 60 is 3,600. You take that and you divide, and that gives you a 58 and 2/3 feet per second, or the repeating 6. So if I round that to the nearest tenth, that's about 58.7 feet per second for the kangaroo. Okay. And one more example. We want to solve this proportion. Okay, remember, to solve a proportion, we're going to do the cross products. So we're going to take z plus 3 over 4 is equal to z minus 4 divided by 6. Okay, so the cross product, z plus 3 times 6, and 4 times z minus 4. Okay, I'll distribute, and I'll get 6z plus 18. 6 times z, 6 times 3, 4z minus 16 by using the distributive property. I'm going to subtract 4z from each side. And they don't really show that here, and that is a step that I would actually like you to write. Once I do that, I get 2z plus 18 equals negative 16. At this point, I'm going to subtract 18 from each side. Again, something I want you to write, even though they didn't in here. So 2z is equal to negative 34. Divide each side by 2. Oh, and I don't need to put the negative sign there, sorry, because they actually have already written it for me. Okay, so divide each side by 2, and z equals negative 17. Okay. Also in your book, they do give a couple of more simpler examples of solving proportions. In your book, they're example 4 and 5 on page 144 and 145, if you want to go and do that, just for your own benefit. In the meantime, then, before you get to class, please complete the quick check questions, and I look forward to seeing you very soon. Thank you.